All right. Hello, everyone. As you're coming in, please use this. QR codes are back, so use the QR code to download SampleOx, and we are going to be capturing your sweet, sweet data throughout this, and we're going to be using it. So go ahead and download that. And you have 3 samples in front of you. Please don't completely wolf them all down, because I'm going to ask you to taste them in the middle of the talk as well. But one of the first things that we are going to do is taste those while they're cold and fresh and bubbly and cute. All right, so you all have 3 samples? Cool. And I'm purposefully not telling you what they are. So this is a blind tasting for now. You should all be able to get into the ballot. The ballot is really, really simple. It is basically just how much do you like each sample, and pick some flavors that you're experiencing in each of the samples. Best practice is to pick 3 or 4 flavors. It's just check all that apply. So boop, 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 pretty easy. Another best practice real quick, I'm just diving right into this so that you guys can get it tasted. Another best practice is to just taste in different orders. So not everybody should be tasting sample 1, followed by sample 2, followed by sample 3. If that's all you can handle with your cognitive load this afternoon, fine, I get that. But for those of you who are a little bit more spry, maybe you taste sample 2, then sample 3, then sample 1, or 3, 2, 1. I know, you're like, absolutely not. So if you're feeling it, do that. Yeah. That's what I lovingly call self-randomization. So you're just randomizing yourself, okay? All right, so I'm going to give you guys a couple of minutes to do your evaluations while we're all settling down. Please don't drink all of them. I know that number 3 doesn't have a ton, but we have a little bit more at the front here, so we'll be able to refill you guys. So just don't drink all of it, though, unless you're going to drink all of number 3. Actually, still don't even drink all of number 3. Let's give them Yes. So please go ahead and do your evaluation now.
You need to set our cheddar is just for beer.
Oh no, sorry.
Oh, do you want me to blow it up?
Yeah.
They need to steal their idea.
So do all of your evaluations right meow, and then we're going to talk about it, and it will all make sense. Yes.
Sorry, quick question. I was just at the last option.
They're adding
Yeah.
other way through shit.
I was so pissed at them. I was like, are you kidding me? You're doing hop grinds before my session? Just keep doing it. You're just one person. You're just one guy. Yeah. Yeah. No. We're not going to hold you to anything. Yeah. We're not going to hold you to anything. It's the just follow the QR code. Either use the QR code, or it's at the very top of the. It's at the very top. It's called Tasting and Making Thiols. All right. So you guys are all great sensory panelists because you're all doing your evaluations independently. I usually have to tell people to stop talking. So keep doing that, and we're just going to give you 90 seconds essentially, and then we're going to go into our talk. You can keep on doing your evaluations, but we have a lot of content to get through.
Some space? No, sit. Or are you going to sit? Stand. Yeah.
Okay, so we're going to go ahead and get started. If you haven't finished your evaluations, please finish your evaluations. Again, we're not grading you. You're going to be fine. You don't have to give yourself too much pressure. So I'm just going to do some quick introductions, and then we're going to just dive right in. But again, if you're not finished evaluating, you don't have to look at me in the eye yet, but eventually you will. So my name is Lindsay. I am a sensory specialist and CSO and co-founder of DraughtLab Sensory Software. Before DraughtLab days, I was working for New Belgium Brewing Company, where I was a sensory and consumer research specialist for about 10-ish years. And the app that you guys are using today is one of our apps. It's for consumer research, so you have me to thank. A little bit more, I always like to give a little bit of an introduction so that you guys are like, oh yeah, I should be listening to these folks. I have been studying beer for a long time. I went to UC Davis. I also teach at UC Davis, the sensory course for the Master Brewers program. I've taught that for about 4 years now. And studied food science and technology, focused on gluten-free beer, fell in love with sensory along the way, and then at some point, I became a sensory scientist before a brewer, whereas I used to identify as a brewer/sensory scientist, but now I'm more of a sensory person. So we work with hundreds of different companies throughout food and beverage, but my heart is still in beer. So I'm pretty excited to talk about tasting and making thiols with you today. And it's going to be Allison and I, so we're going to go back and forth. And I'll pass it to Allison.
Excellent. So my name's Allison. I'm the R&D molecular biologist at Omega Yeast. We're in Chicago. My background is that I was a brewer for about 10 years in the DC area. So I brewed for a place called Port City, and then 3 Stars, and then most recently was head brewer of Old Ox for 5 years. And prior to that, I was a yeast scientist. So I have a PhD in biochemistry, and I did my research in yeast. So I've definitely been playing with this beastie for a while. So that is my background. Today, obviously, we're going through thiols from more of a sensory perspective. So this morning, there were a couple of really good talks on thiols that went through some of the basics of how you make these kind of strains and some of the hardcore science. And we're mostly going to kind of approach it from a taste and aroma perspective today. However, we still need to know what these things are. So to start off, what are thiols? As you guys know, they're the characteristic flavors that are in beer and wine. Most particularly, it's the flavors in Sauvignon Blanc and in hops like Nelson Sauvignon and Hallertau Blanc. They are what give fruits their kind of tropical aroma. So the same compounds that you're tasting today, the same thiols, are actually what give those fruits their flavors. And they're super potent. As you guys have probably seen already, it's really easy to kind of blow yourself out on them. Doing quick drive-bys is all you need. Humans are really, really sensitive to sulfur compounds. What thiols actually are, they're very similar to alcohols. So up on top, is one we know and love. An alcohol is just an OH group on the end of a chemical compound. And a thiol is just when you have an SH group on the end of a compound. And that's all it is. Thiols form the signature aroma of a lot of different products that we're familiar with. So in coffee, they provide the kind of roasty notes. Those are thiols. In different kind of fruits, they provide the tropical notes. That's in guava, passion fruit, grapefruit, black currants, raspberries, things like that. All of those are thiols. It also provides the skunky note in cannabis. As you guys know, hops and weed are pretty related, and it's not surprising they have the same kind of compounds, and so thiols are responsible for those kind of flavors. Like I said, people are really, really sensitive to thiols. Just to give you some perspective on that, if you think about an Olympic-sized swimming pool, it holds 21,000 barrels, which is kind of strange because if you think about the output of a brewery, like a big brewery, it fills an Olympic-sized swimming pool. If you're looking at something like your perception of an ester or an aldehyde, so something like a trans-2-nonenal or like an isoamyl, it would take between 5 beers and 21 barrels of that dumped into that pool for you to be able to perceive it. That's a parts per million concentration. If you're looking at something like diacetyl that has a parts per billion threshold, you would need to put in between 2.5 mils and 5 beers into that pool before you could actually perceive it. But for thiols, all you need is 2.5 microliters to 2.5 mils in that pool for you to be able to tell it's there. So 2.5 microliters, that's like a tick, that's like a freckle. It's amazing how sensitive people are to these compounds. There are a lot of different thiols that people have studied in beer and wine. This is just a summary of some of the most common ones. The one you'll probably hear us talk the most about is 3SH. It gives you grapefruit and passion fruit vibes. It's also the one that is most prevalent in Sauvignon Blanc. It's important to know that there are lots of different kinds of thiols out there, including lots that we haven't studied yet, but those are the ones you kind of hear most about in the beer world. These compounds have different sorts of signature flavors to them. So some of them lean down a tropical pathway, some of them lean down sort of like a diesel, skunky kind of pathway. And it kind of just depends on which one you get, what kind of flavor you get. Just a quick history on 3SH, which is one of the ones that is most prevalent in beer. This is kind of new studies. Part of it is because these things are so volatile, they're kind of hard to study. They're hard to isolate, they're hard to measure. So it wasn't until 1991 that people actually found 3SH in passion fruit. More recently, in 98, it was found in Sauvignon Blanc wine. The wine world has really been ahead of us as far as thinking about thiols in their beverage. Part of that is because grapes are a great source of precursor. Of course, we know that we have great sources of precursor in beer too, but the wine world has known about this for much longer than we have. In 2002, it was found in grapefruit. In 2005, it was found in guava. And then most recently, in 2006, it was found in beer. And if you read this paper, basically their premise is just, hey, there are these awesome compounds out there. No one's really looked to see if they're in beer. Let's see if they are. And they actually looked in a lager strain, and they found 10 different thiols at extremely low levels. So even without having any kind of thiolized strain, even without having any kind of genetic manipulation, these things have like very low levels of flavor compounds that are thiols.
Cool. So now that you have a little bit more of a background of what thiols are, I think we talk about thiols a lot, and it's like very buzzy, but it's just a little molecule, little sulfur guy. So you can think about that little guy bouncing around, being all volatile, and getting into your nose cavity. So now that we know what those are, what we wanted to do was start talking about what is the impact that they have on beer. And I think we all kind of anecdotally know that, but like what Allison said, there's been very little research to date on what is the impact on consumer preference. What is the impact on how much is too much maybe, or how little is not enough. So we started to kind of chip away at some of these questions. So we've been working with Omega to conduct a couple of different studies, to design some studies, and start answering some of our hypotheses. So when we started talking about, I don't know, like 6 or 8 months ago or whatever, when we were coming up with ideas, we came up with 4 different hypotheses. And I want to go through each of them today and show you a little bit of data that we've been able to capture at Omega and that we're evilly capturing with you today. So number one of our hypotheses was more tropical flavors with thiolized yeast, right? Like I was even talking to somebody earlier today that was a total naysayer. I don't think he's in here, I'm looking for him. And he was just like, thiolized yeast has nothing to do with that. I was like, come to my talk, you'll smell it. So we just wanted to actually definitively answer that question. Do we actually see more tropical flavors specifically with thiolized yeast in beer? Our second hypothesis was it matters. There's a consumer impact that people like thiols, okay? I'm from the West Coast, and thiolized yeast is not as much of a buzzy thing. I'm like, what is all this fruity stuff? It's such a thing here. I remember the first one I had. I'm not going to digress, but the first one I had was in 2018. I was like, wow. So number 2, people like thiols. Number 3, dry hopping changes the perception of what thiolized yeast can do to your beer. And number 4, we expect there to be a positive correlation with shelf life, which actually, depending on how your brain works, might be negative. We basically think that shelf life is going to increase when using thiolized yeast. All right, so hypothesis number 1, again, that was more tropical with thiolized yeast. How did we answer that question? So we answered that question with Omega. We ran what's called a descriptive analysis panel. And a descriptive analysis panel can mean a number of different things. In this specific case, we're working with a group of trained tasters that have been standardized on a number of different attributes. And what we asked them to do was to scale a number of attributes, including tropical, but there's also some red herrings and stuff in there, to see if we actually saw quantitatively more sensory perception with thiolized yeast. So the 2 samples that we had was a non-thiolized yeast beer, and the second one was thiolized yeast beer.
Was it identical except for the yeast?
Yes, yes. The question was it identical except for the yeast? The answer was yes. They brewed it, but yes. Okay, so more tropical aromas. All right, we are scientists, by the way, so yes, we're like, we love a
Well-controlled.
well-controlled study. Yeah. So the results from the Omega tasting, what we saw was that thiolized beer was significantly more tropical and had significantly more citrus, and those are the p-values there. I usually don't love showing spider plots because they get a little bit confusing, but in this one, it was pretty clear. Like, you can see that little green bar, and you can see the blue bar. The green is thiolized, the blue is non-thiolized, and you can see a big peak on fruity, tropical, and citrus with our thiolized strain. So that's all exciting. All of the other flavors were the same, using analysis of variance. So what I want to see is what you all thought, and we want to add this to our data pool of what we're learning about thiolized yeast strains. So go ahead and pick up number 1 and number 2, and I want to see, we're going to see in real time. It's always risky. Oh, ooh. Thank you, Slack. All right, so we are going to pull it over here. Great. All right. Sorry, it's not showing on both, so it's going to be a little bit annoying for me to do this. So it's always a little bit risky to look at data in real time, but I'm feeling risky, so let's do it. All right. So number 1 was this guy. We had these 2 beers brewed at Half Acre. It's the same beer, 2 different yeast strains. Okay, both of them are Pilsners. So this is the non-thiolized Pony Pilsner from Half Acre. And what we see is your average hedonic score. So we see you all liked it moderately. So 5.88 is kind of like, we like it. Yeah, we like it. Yeah, it's good. I'll buy it maybe. So 5.88. And your net liking score is okay. Net liking score is basically the net promoter score. So it's a level of enthusiasm that you have for the product. And you guys are like pretty neutral. Might tell a friend about it, probably won't. The primary attributes that you all are picking out is cereal bready, grassy herbal, and bitter and floral. So those are the main things that you all are picking out. Cool. All right, great. We saw that. Now let's see. Oh gosh, this is gonna be hard. Let's see number 2. Drum roll, please. Hey! Tropical flavors! All right, so it worked. All right, so number 2 was the thiolized Pony Pils. So same malt bill, pretty much the same beer, just a different yeast strain. And you guys are still kind of neutral about it, which is really interesting. And you can almost see that there's like a suggestion of a bimodal distribution. All the people like 1 to 4 are from the West Coast. And everybody else is like East Coast. Yeah, but it's relatively neutral. There might be a bit of a bimodal distribution. So there might be haters, there might be lovers. That's kind of cool, kind of interesting. But you're equally enthusiastic. Takeaway here, more tropical, more citrus, you know, bitter, fruity is all kind of in the middle there. Very, very cool. So that's fun. Please don't finish sample 1 and sample 2. If you did already, then it's fine. I'm like looking at you. I'm like, oh, he did. That's okay. If you did, that's fine. We actually might be able to get a little bit more, but we're gonna play a game with it later. Okay, so we're gonna go back to our presentation, and then we will keep it going. So we're gonna do this. All right, thanks for playing that game with me. Very exciting. Okay, so we had a second hypothesis, which was people like thiols. Apparently they don't. Some people do. So it's a bimodal distribution. We just have to find the ones that do. So this is the interesting thing, and why I wanted you guys to kind of keep a couple with you, is that was so in our faces, right? That was really, really fruity. So there might be some kind of play in there where liking is enhanced, which is kind of the next step of this research project. I would expect, even though I didn't do stats on that there's probably no significant difference in liking. It was like a 5.66 and a 5.88, probably about the same amount of liking on those 2 samples. So we just answered that question. Apparently it's no with this group of people. And all right, so I'm going to stop for now, but we're going to do some more tastings.
Right, more beer to come. All right, so we figured out what thiols are, we figured out what they taste like, and now we want to talk about, how do we actually make these things? There's two main ways of doing it. You can use ingredients that have lots of free thiols, or you can use lots of ingredients that have thiol precursors, and then use a yeast that can release those free thiols. So as far as introducing lots of free thiol, that's pretty easy. You just use hops that have high levels of free thiol. Those tend to be the sexy ones, so it's things like Citra, Nelson, Mosaic, Simcoe. But then the one we're kind of interested in this talk is how do you make thiols from precursors? So where precursors come from usually is from your barley is the biggest source. They are a consequence of fatty acid metabolism. There's this compound called E2-hexanol that looks a lot like the basic part of 3SH. So it's this part down here is basically what E2-hexanol looks like. And under stress, plants actually conjugate that to glutathione, and that glutathione, big thing on top there, is a precursor for thiols. There's a couple of different breakdown steps that happen that it takes you to some precursors that are easier for yeast to deal with, most notably the cysteine conjugated 3S. Then that can be turned into 3SH through the action of a carbon sulfur lyase. That's kind of the terminology that people have settled on across different yeast providers. And then you get your free thiols. So basically what happens is you have these precursors that are taken up, you get processed into this nice precursor, and then through this enzyme you get your very aromatic compound, the free thiol. Like I mentioned, the biggest source of these things is your barley. That's where most things are going to come from. It's the biggest ingredient in your beer. It's obviously the most poundage. It's where the kind of the backbone of your beer comes from. It's where most of your precursors come from also. It can come from hops as well. So kind of the opposite of your sexy hops are the ones that tend to be high in precursors. So things like noble hops or your kind of traditional C hops are the ones that are highest in precursor. It can also come from things like grapes. So there are lots of precursor products that are out there that often come from grapes or from other fruit products. As far as the yeast that have these carbon sulfur lyases, they are genetically engineered yeast. In the case of Omega, we have two different flavors of genetically engineered yeast. Cosmic Punch has an enzyme, its carbon sulfur lyase is IRC7. And then we have three strains that are called Star Party, Heliogazer, and Lunar Crush that express a protein called PAT-B that cleaves those free thiols. So basically, like on the bottom there, you add your precursors, you add your yeast with an active carbon sulfur lyase, and you get free thiols. As far as the comparison between these two types of strains, Cosmic Punch and Heliogazer, for example, have London 3 as a base. We call it British 5. They have two different enzymes, and the biggest difference there is that they have different levels of thiol output. Basically, IRC7 produces about 10 times your sensory threshold of thiols, but Heliogazer, as well as Star Party and Lunar Crush, produce 300 times your sensory threshold. And so basically this gives you two different kinds of tools, depending on what kind of beer you want to make. Cosmic Punch is a great beer to kind of use as a house strain. It's one where you're going to get kind of lower levels of thiol, kind of something that can more play with your kind of fruit punch kind of aromas of your hops. But Heliogazer is a good tool if you really want to get a ton of thiols. Of course, there's also tools you can do to kind of dial that in, and we'll talk about that later. But you basically have a lot of tools for kind of figuring out how thiols can play with your recipes, and there's lots of different ways you can kind of enhance or decrease the presence of thiols in your beer. And once again, like if you have the PAT-B enzyme, which is the Heliogazer, then you're going to have a much bigger perception than the IRC7. Looking at your grain as being your biggest source of precursor, this is just a graph showing you finished thiol in a finished beer that's just made with grain. So there's no hops here, there's no thiol like precursor addition, it's just grain being brewed. And you can see on the left is your threshold, so it's about 60. That's the level at which you can perceive this. If you use just the plain old 011, which is London 3 or British 5, you can see it's a little bit of an increase, but not much. Basically, that's no change. However, when you use heliogeyser, which is the London 3 with the souped up enzyme, you can see that you get tons of thiols, free thiols with the 2-row. You get a moderate increase with Vienna malt, a moderate increase with Munich, and almost nothing with white wheat or with oats. So that's kind of a tool for you guys to play with. So you can use this really souped up thiolized enzyme, but if you think it's too much for your tasting panel or how you want your beer to taste, you can dial it back using like white wheat and oats as part of your grist. So it's just kind of a tool for you to play with in your recipe building. Cool.
Okay, so our third hypothesis, to remind you, was dry hopping is going to change the perception of thiols in beer. And so to answer this question with the expert Omega panel, we did the same thing. We did descriptive analysis on a small subset of flavor attributes, the same flavor attributes that you all did check all that apply on with the tool. So we did descriptive analysis with Omega, and we looked at two different things. We looked at one, the non-dry hopped thiolized beer, which is number 2 for your sample, and the dry hopped thiolized beer, which was number 3, which we'll look at the data in a second. So what did we find from the Omega panel? So what we found is when compared to the non-dry hop thiolized beer, the dry hop thiolized beer is less tropical. So adding hops decreases the tropical flavor. So less tropical, hops on the cold side, less tropical, and less sweet. It wasn't literally less sweet, but the perception of sweetness is lowered. And then we also saw more citrus flavor and more bitterness. Not sure if it was analytical, but sensory definitely was the case. So that's also kind of an interesting thing. So again, if it's a little bit too thiolized, fruity, sweet, dry hopping kind of mellows that out. So I'm curious what you guys thought between samples 2 and samples 3. We have more sample 3 here. We really rationed it, so if you need more sample 3, we can do that. We asked for 2 cases and we got 2 4-packs. Sorry. So you're like, all right. So if you need a little bit more, then you guys can pass it around. Yep.
Why does dry hop?
I think a lot of masking is happening, so it's not necessarily that like chemically, and Allison can probably answer this too. Like why does dry hopping influence?
We're not sure yet. I'll get to some slides later about some interactions with esters and terpenes. But as far as like why it goes down, that's still something we're researching. You know, whether it's just like adsorbing onto the hops or onto the yeast, we're not even sure yet. Source of research.
Yeah. Yeah. So you guys already saw number 2. So number 2 was the thiolized pony pills. You thought it was pretty tropical, pretty citrusy, but mostly tropical, right? And then bitterness was the third attribute. So that's a reminder. So now when we add hops to that, this is a bit of a different beer, so we're not perfectly scientists in this case, but we saw not much of an impact. It's like really tropical, also citrus, fruity, bitter, and sweet. And liking was all about the same. Brewers are just like, everything's only okay. Yeah, it's a tough crowd. Yeah, a tough crowd. It could always be better, yeah. So maybe the wrong crowd to ask. So again, it was relatively neutral, 5.85. Again, maybe potentially a bimodal hedonic distribution. What I expected, if this mimicked what we did with Omega, what I would have expected is for the citrus to have taken over the tropical and the tropical to have gone down, and I would have expected for the bitterness to go higher than the sweetness, but that's humans for you, so we didn't see that. So that's kind of interesting. And the liking was about the same, so you guys aren't helpful at all. Yeah.
All right, so we saw what happens when you build a basic beer with just barley, but what happens when you add hops? As we saw, all right, maybe we didn't see a lower tropical hit, but I guess what I want you to think about is your perception of thiols in that beer. When it was just the bare bones beer, I think thiols is a major component of your tropical. And when you're looking at this dry hop beer, I think hops are a big part of that tropical also, right? So there clearly is some sort of a perception change in sort of how we're getting thiols in a dry hop beer. Like you guys asked, the question is, like, are thiols actually going down, or is there some sort of like masking? That's something that we're still kind of trying to figure out. It's not something we've done anything quantitative on yet, but it certainly is something that that you do perceive. So the real question is kind of, all right, what's going on here with dry hopping? On one hand, we have this perception of where it's going down a little bit, but on the other hand, we see this interaction between thiols and both esters and terpenes. So if you focus on the left here, these are some spider plots for tasting of 3S4MP, which is a thiol. And then it's done either by itself or in concert with a different thiol at a level that's below your threshold of perception, or an ester below the perception level. And what you see are different kinds of plots. The most important part was in part D here. So the dark line right there is what 3S4MP looks like by itself. However, when you add in this thiol below your tasting threshold or this ester below your tasting threshold, you see a significant difference in how you perceive that first thiol. So if you look at it, I guess it's the other way around. I take it back. It was the light one, it's the dark one. Where previously you got perceptions that were kind of smoky or green, when you add it with these esters, you transition into more of a flowery or a fruity perception. And so that says that these thiols, when you put them in the kind of like the arena of your beer where you have these esters and things floating around, it actually changes how your thiols are perceived. So it's interesting because you can kind of think about how a thiol in two different beers, depending on what kind of hops you've put in there, what kind of base grains or what kind of fruits you're putting in, might change, which is really cool for recipe building. So a lot of different tools out there for you to play with. Similarly, if you look on the right, you can look at the interaction between thiols and terpenes. So here we're looking at 4-MSP, which is a thiol, either by itself or in combination with a terpene mix. In this case, it was with linalool, geraniol, and beta-citronellol. You can see what 4-MSP is by itself, what the mix is by itself, and then the last one is the combination. So you can see that 4-MSP by itself was the kind of lighter one, and then with the mix, it's the darker track. You see it's a major skew towards tropical when you have thiols and terpenes together. So on the one hand, if you have terpenes from your hops that maybe are masking some of your thiols, that's kind of one interaction. But then you also have interactions like these where you get a much more tropical hit. So basically right now, we're still trying to figure it out. All of this stuff is new, which was part of the message that I wanted to make with that timeline in the beginning. And we're all figuring it out with help from you guys. So kind of some of the things to think about are, what is the threshold of these compounds? So how much do I need to get to be able to actually perceive it? Masking interactions or synergy interactions. So, are the esters interacting with my thiols to make it so I can perceive more? Are the dry hops actually masking it? And then is there a point where there's too much? Quite frankly, with these souped up enzymes, if you put all the tricks in there, so if you use a low kiln malt, if you mash hop, if you throw in all of these like kind of thiol precursor compounds, there's a point where to some people who are really sensitive to these compounds, it's just too much. It like overtakes the beer. So trying to figure out kind of how you dial all these flavors in for your beers is kind of where we are right now. And our game is kind of trying to give you all the tools to do that. So hopefully we'll be able to do that soon.
All right, who needs more of sample 1 and number 2?
Come on up.
Okay, you guys can pass there. You can come on. This is number 2. This is number 1. Number 3. Sorry. Okay, so Allison kind of, yep.
Have you guys tried with like precursors of the malt with like local stuff versus like more manufactured stuff? And if like having more precursors make it that much more amplified?
Certainly, yeah. We're starting studies right now where we've looked at some of the big makers, but then also some of the smaller guys to try and see what the levels are. The biggest trend is that things that are lowly kilned have higher levels of precursor, and so it kind of just depends on the process of your local folks. That's work in progress. Yeah, something that's really interesting. That study that had the Vienna and the Munich, that's kind of the tip of the iceberg on what's coming. So yeah, but yeah, I mean, I think it's a great option. It's kind of playing with what you have around. There's a beer that was made, I think it was in the Virginia area by Elder Pine, I think it was, where they used wind kiln malt, and that beer was beautiful. It was a lager that it was all tropical. It was great.
What about like raw or flake barley?
That's a good question. My prediction is that flake barley would be great because really there's very low kilning, right? That like you're not heat inactivating any of these things. We haven't officially tested that, but that would be my prediction.
All right. So Allison kind of referred to finding the right balance is kind of the fun, tough thing, and this is just for fun now. So let's have fun. So I like to take a little bit of number 2 and just add some of 2 into your number 1 until you get what you like. It's fun. This is really scientific. Did you add a splash? Did you add a skosh? Did you add...
So number 2 is not dry hop.
Correct.
No, it was not dry hopped. No.
Number 2 is exactly the recipe for pony, just pulled off into a different fermenter and just do it for it.
Yeah, so 1 and 2 are the same beer.
Number 2 is lunar crush yeast.
What's
Number
the
2 lunar crush yeast.
Correct.
So I don't know about you, but I added a splash, and it like mellowed it out. To me, I'm like, that's fun. Like this is a little bit more fun for me. Cool. So that's a good time. Let's do the same thing. If you happen to have a little bit more of number 3, then it might be kind of fun to find the right balance of number 3 and number 2 as well. So add a little bit of sample number 3 now into your sample number 2. So hopefully you did that the right way, because if you added 1 into 2, I was trying to be as... It's tough. I don't have any 3, so you'll have to just depend on you guys. Was that kind of fun? You had a good time?
I'm gonna go back.
Cool. All right, so we're going to wrap this up a little bit early, so there's going to be lots of questions if you want. So number 4, our last hypothesis that we had was that we would potentially see shelf life improvements. And because the study is relatively new, you're going to have to stay tuned. But basically what we did is we asked Deschutes to essentially do descriptive analysis and shelf life on their new Cosmic Creatures IPA that only came out like a month ago, so it's still pretty fresh. So we looked at 2 different samples. There was a super fresh BBT and a 30-day package sample. And what we found is when we compared the 30-day sample, when we compared a fresh sample and a 1-month-old dry hopped thiolized beer. Wow, that was a lot of things to put in there. I should make that easier to understand. What we basically saw is that they were equally oxidized, quote unquote oxidized, which that's, a broad, weird term that I really don't like using. But that's what their panelists trained on. So it's essentially aged. So we really didn't see any difference in shelf life scores. The only thing that we saw for descriptive analysis is after 30 days, there was less sulfur. And I just smelled number 2, and there is definitely some sulfur in there. So I wonder if that actually just anecdotally from the Deschutes panel, they're like, we actually like it at 30 days a lot more because that sulfur kind of mellows out a little bit more. And when I added number 2 into number 1, I thought the sulfur kind of like mellowed out too. So there's some suggestion, I'm sure you've seen that too with your panel and like the sulfurs as well, that they kind of end up dissipating relatively quickly. Again, we only have 30 days, but stay tuned for more. I'm going to give you a QR code to our blog post. We'll write a blog about it. Yep.
Can you talk more about the sulfur notes?
Talk more about them? You can probably talk about them.
We see that sort of as a thresholding thing. It seems like it's really sort of a personal perception thing. Across, like we said, we have a team of very talented, very trained tasters. And there are some people who never get sulfur notes, and there are people like me who always get them. So they travel together. And for me, I like them at a certain level. It comes across the same way as like a lager sulfur a lot of the times, which is an accepted flavor in a lager. It just is what that tastes like. For other people, it'll be different. And that's kind of where the thresholding comes in. Like, is there a point where it's too high? For me, there's a point where it flips into just sulfur when you get when you really max it out, when you really play all the tricks, right? And so I think every team has to kind of figure out what that is. I think if I was not on our team, we would tolerate a lot more. So it's kind of like a matter of kind of figuring out what tastes good to you. Because I think they add a really great tropical note that can play with a lot of different stuff, and I think they're really interesting on their own also, but you just have to kind of figure out levels.
How do they compare to the tropical notes?
I don't have quantitative numbers for that because it's hard to put a finger on which of the sulfur compounds you're getting as far as measurements for those. So measuring sulfur compounds is really complicated. If you have a typical GC like we do, one that can do VDKs, for example, you can't measure thiols because you need an entirely different column. When we do this kind of stuff, we send it off to a lab in France. So doing these kind of studies is pretty complicated. It really comes down to perception because that's, we're making beer, we're tasting it, right? We found that yeast health plays a big role, so don't underpitch, make sure you get a nice healthy pitch in there. You tend to push towards the tropicals. And then just kind of dial it in based on what you like. So that's actually what we're about to talk about, is that when you're brewing these thiol beers, there's kind of two different approaches that you can take. You can make a super thiol dominant beer, or you can use it where thiols kind of complement the rest of your beer. And there's sort of two different tacks you can take, right? So we have different yeasts. So we have ones that produce low levels of thiols. We have ones that produce high levels of thiols. If you're wanting to really maximize thiols, you can use mash hopping. The idea behind that is we talked about those precursors and how some of them are harder to turn into thiols and some of them are easier. The idea is with the mash hopping, there are enzymes that transform the harder to change ones into the easier to change ones, and that's kind of the idea behind that. We advocate that if you're using something like Cosmic Punch, because I didn't put it in here, but if you're going from a level of, you're measuring 3SH at 200, you go to 300 with mash hopping, and that's a big difference there. With the souped up enzymes, so if you're using Cosmic Punch, if you're using Star Party, for example, you're at 6,000 without mash hopping, and you go to 6,500. So that difference that you get from mash hopping doesn't really matter on that. So it's a tool that you can use to increase it if you're using the lower one. You can also choose to use hops that have free thiols, and that's a way to kind of soup it up. If you want to tone it down, there are ways where you can, for example, use more oats or wheat in your grist. You can choose whichever hops you want that have less precursors, for example. You can use base malt that has a little bit of a higher kiln on it to get a little bit of less precursor. So right now we're at kind of a really fun stage where we have a lot of tools. There's stuff like Phantasm that I'm sure you guys have heard about, all these different kind of precursor additions that you can add. Figure out if you like them. That one, it comes from grapes. You get a little bit of a grape note. Is that something you like? Is it something you don't like? You can build a beer around all these different kinds of tools and kind of figure out what you like. So we would encourage you to kind of play with those kind of things.
All right, so some conclusions and next steps. Thiolase yeast, they create tropical aromas. You proved it today. Do these flavors correlate with liking? We saw with this group of brewers, you don't like anything, so no. And the impact is balanced with dry hopping. We did kind of see a little bit more of a balanced flavor, overall rounded flavor with dry hopping. And some of our next steps we already kind of alluded to. We want to follow some of the samples through shelf life. If you're going to be at CBC, we'll have one more month at least of shelf life data, and we'll be talking about that. You can do some experimentations with interplaying thiols, terpenes, esters, and more. And so just a quick shout out, so thanks to Half Acre Brewing Company. They made these beers, and Equilibrium made the third one as well. And we'll go ahead and open it to questions, but I did want to throw out, if you guys are interested in continuing our just general sensory conversation, we put out a lot of tidbits on our newsletter, so we'll definitely be writing a blog post about this study in our newsletter relatively shortly. And we also just wrote something about just doing this kind of thing in your tap rooms as well. So feel free to just sign up for the newsletter. And with that, I think we'll answer some questions. Yes?
Do we know what the hopping rate was on sample number 2?
I don't know the particular details of how they make Pony, but it's their flagship Pilsner at a very well-established brewery. So you can imagine how they make that Pilsner. My suspicion is little to none. I know that it's Pilsner, so I'm sure it's Pilsner malt as a base. I know it's made with noble hops. That's about all I got. Other than that, I think it's a pretty typical Pilsner recipe.
I just want to ask the same question I asked the previous thing. Of the sulfur compounds, have you noticed an increase in light struck character if you, for example, pour a stylized beer into a clear glass,
Right.
put it out on a cabinet on a sunny day?
My understanding of light struck is that it's a certain hop compound that breaks down into that kind of skunky aroma. And I'm not sure if that's a thiolized compound, but that it's a very specific chemical interaction. We have not. Oh, it's a mercaptan. I'm not sure. We have not anecdotally seen anything like that, but could be something to look into if it falls down that pathway, certainly. That being said, I mean, just don't skunk your beer. I mean, right.
I always drink in the dark, yeah.
Yeah, in the back there.
Have you guys looked at how ABV affects thiol perception? I mean, I've been using Cosmic Punch for about 2 years as our house strain, and I feel like anytime you use it in something that's lower ABV, like a hazy pale ale, the sulfur's through the roof. And I don't know if it's like the malt bill or the hop bill, but it seems that anything like under 6%, in the beginning at least,
Yeah.
is super sulfury.
Interesting. So you bring up 2 points there. One is the in the beginning part, that these things are volatile. So sometimes you get those perceptions in a very young beer or a very fermenting beer that then are kind of driven off. So sometimes age can help that out. And thinking about like the way these beers can mellow, like throughout lagering, for example, they do change and perceptions do change. As far as low ABV changing your perception of the sulfur, we haven't seen that as a trend. And I'm surprised that it goes that direction because we have seen a correlation with yeast health and overall fermentation character. And I would expect a healthier fermentation with the lower ABV beers. So I'm surprised by that. I guess I would look at the rest of the variables in your recipe and just see if you can build something that is as close to a controlled experiment as you can. So, using the same base malt, using the same hops, and then just building it at different ABVs and testing it in-house with your techniques. But no, in general, we haven't seen that trend, but obviously everybody sees different stuff. So yeah, I would try and tease it out in-house.
No, not crazy. There's a definite haziness increase in
Yeah, I think that's mostly process. That's that, Half Acre's a big brewery with a 50-barrel brew house and giant tanks, and Pony went through its regular system, and this is their 5-barrel pilot. And it lagered a little less than they were not comfortable with, but they usually do. Mostly because this is the same beer we're taking to CBC, so we were trying to kind of like hedge our bets on like making sure it tasted good for both talks. That's not something that's characteristic of that strain. For all of these thiolized strains, they behave like the parent with the exception of this thiolized change. That's part of what we verify. Everybody feeling? Oh, I got one in the back.
I don't even have a question. Your Cosmic Punch is amazing, so
Thank you.
for that.
If you guys could all just say stuff like that would be great. Yeah.
It's great.
I appreciate it. Thank you. Well, cool. On that note, because I'm definitely ending there. That's amazing. Thank you so much for coming out. I hope it was great.